This is just a real quick warning that some clips are used from previous editions of your textbook, and the titles might not match up, but all the content is really just the same.
Let me give you some examples of functions. First of all, let's say you've got a number of books that you're going to sell at a used bookstore, and you're going to charge, every time that you sell a number of books, they charge $2.50 per book and then a $3 flat fee. So if you have one book like this, then you can fill out the table and you see 250 times 1 plus 3 is 550, and you could plot the point 1 comma 550 on a graph if you wanted to. Same thing for two books. 250 times 2 plus 3 is 8. 250 times 4 plus 3 is 13. 250 times 7 plus 3 is 2050. And 250 times 10 plus 3 is $28. And you get all these points, and you can plot them on a graph if you want. The thing that I want to say is that it's very predictable. It's if you give me a number of books, then there's only one possible number you could have for the amount of funds raised. It's not like 20 books could give you maybe $23 or $24. No, we could figure out exactly how much money you're going to raise given the number of books. Very predictable output. Cell phones also have very predictable output. You press a button and there's a very specific action. If you tap the home button, then it'll display the home screen. Hold the power button and it'll turn it on or off, predictably. Cell phones and most electronics in general are built on functions because functions have very predictable output. Put something in, the same set of initial conditions will produce the exact same action every time. So for this next example, I have a guest speaker. This is my wife, Mrs. Corinne Bergman. Say hi to everybody.
Hey, everybody.
So she's going to help me perform a song called Let Me Clear My Throat. It was put out there by DJ Kool in 1996. And back in the mid-90s or so, hip-hop DJs were actually live performers, and they would try and get the audience involved. So I'm going to be DJ Kool, and my wife is going to be the audience. And so it's kind of models input-output. So it goes like this. Now, if y'all want to party like we do, if y'all want to party like us, let me hear you say, ah, 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 ah.
Ah, 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 ah.
Now, when I say, you say, ah,
Ah, ah.
When I say, hey, you say, ha, hey,
Ha.
hey.
Ha.
When I say, you say, ah,
Ah. Ah.
So we can kind of think of this as a function because every input has exactly one output. Like, DJ Kool was a master at what he did, so he let the audience know exactly what to do based on what they heard. So if he said, they knew to say, ah. There was no confusion about that. They all responded immediately. And then the next thing he would do, he would get to a part of the song where he would be like, when I say freeze, y'all stop on a dime. When I say freeze, you just freeze one time. When I say freeze, y'all stop on the dime. Freeze! And so everyone would strike a pose. Some people would flash deuces, and other people would give a GQ look or top model, whatever it was. Everyone was able to kind of do their own thing, and it was a lot of fun. But as soon as they did that, it actually stopped it from being a function and turned it into something that's not a function because he allowed people choice, and people did different things. So as soon as he allowed people to do whatever they wanted when he said freeze, it's no longer a function.
So I can't say it enough. With functions, input has predictable output. It's not a function if any one input has more than one output, as I've said right here. Check it out. Here's how your book describes it. Like this. If you got a number in the domain, here are the inputs, right here. And here are the numbers in the output. The collection is the range. And actually, these are generated by squaring them. So -3 squared is 9, 3 squared is 9, -2 squared is 4, and so on. 0 squared is 0. Now, is this a function? The question is, does any one input have more than one output? Well, check this out. If I say -3, then you can say 9. If I say +3, then you can still say 9. And it's actually relatively predictable. -2 goes to 4 every time -2 goes to 4. It doesn't go to anything else. So yes, this is a function. Is it a function? Yes. When I say the state, then you say the senator. Ready? Florida. Oh, you don't know. You could go to either Mac or Graham. Illinois. You could go to either Dixon or Simon. Arizona, you could go to McCain or DeConcini. So this is, because it's unpredictable, you don't know which senator to report when I say Florida, Illinois, or Arizona, then this is not a function. Not a function. Maybe I shouldn't write it directly on there. So if you switch the domain and the range, I'll give you the senator, you give me the state. Ready? Mac. Yeah, you went to Florida. And there was only one option for you to go to. Simon. Yep, you went to Illinois. So, yes, this is a function. I'll write it up here so you can still read it afterwards. Yes, this is a function. I'll give you the year. You give me the revenue in millions. Actually, it's just going to be like 40 billion. So, 1992, right, 48 billion. 1989, 35.8 billion. So, yeah, you get the idea. This is a function because every input has only one output. I was able to get rid of this, eliminate this as a function because an input had more than one output. If it's just one input has more than one output, then the whole thing is not a function. Check us out here. Which of the following relations are functions? So we've got 5 different relations. Let's take relation letter A first. So I'll give you the input and you got to shout out the output. Ready? 5. I'm looking right here. Yep, the output is 8. 3. The output is still 8. That's still fine. 9. Well, you could shout out 0 or -1. So because you've got 2 different options, this is not a function. Why? Because of the 9. This input has more than one output. All right. B. Ready? 9. Yep, you said E. -5. B. 0. T. -2. Q. Sure, this is a function because every input has exactly one output. Next one, C. -3. 7. 4. Yes, this is also a function for the same reason. All right, D. I'm seeing, this might get a little tricky. I'm seeing lots of 0s and 1s. So let's just shout out the input. Ready? 1. Yep, you said 0. 0. You said 1. Good. -1. Yep, this is still a function. 7. -7. -7. Still -7. That's fine. Every input still has one output. Even if the output has more than one input, that's not a big deal. Function notation looks like this. F of x. It's pronounced f of x. It does not mean f times x. I can't stress that enough. When students first start working with f of x, a function notation, they think that there's multiplication right here, and there is not. It's just a simple way of saying this is the name of the function, we're going to call it f, and this is the input, we're going to call it x. And this is how you produce the output. You take the input, you multiply it by 2, and you subtract 3, like this. F of 0 is equal to 2 times 0 minus 3 equals -3. Okay, so what I did was I know the name of this function is f. I know that the input is 0, and I know from the definition here, this is going to be, I'm going to take the input multiplied by 2 and subtract 3. So that's exactly what I did. I took the input, 0, multiplied by 2, subtracted 3, and I got -3. That's the output. 0 goes to -3. The input, output. Here's the input, it's -1. I'm going to put it into the f function, and this is what I get. 2 times -1 minus 3 equals -5. -5 is the output. F of A is going to be the input, and actually we can't really compute anything here. We can simplify, but you can't combine like terms. That's really all right. The input can sometimes be a letter that you can't simplify. Not a big deal. You can even have an algebraic expression, f of A plus 1. You put it into the function 2 times A plus 1 minus 3. Still not a big deal. You can simplify a little bit to get to 2A minus 1. There it is. What if we redefine f to be something a little bit more complicated, like a quadratic? Still not a big deal. You can plug 0 into this. 0 squared, 5 plus 5 times 0 plus 1, it's still going to equal to 1. F of -1 is going to be -1 squared plus 5 times -1 plus +1. Now here's where the parentheses are really important. And my recommendation is that you overuse parentheses. Just use them all the time. Sometimes they'll be incredibly helpful and sometimes they won't, but just get in the habit of doing it. The handwriting is not really all that much. -1 squared turns into +1. If you type this in on a calculator, -1 squared without the parentheses, order of operations first, they'll do the exponent and then it'll do the -1 on the same line as multiplication. And the calculator will produce -1. But if you use parentheses on a calculator, then you get the +1 that we're looking for. 5 times -1 is -5, and +1, +1. Add them up, you get -3. Here, f of a, I'm still using parentheses, even though the only simplification is just to remove them. Just out of habit, it's a good habit to be in. A squared plus 5a plus 1. And then you can still plug in f of a plus 1. You get this plus 5a plus 1 plus 1. And then, of course, you'll have to distribute. And here you'll have to FOIL. Remember, 2 terms FOIL, 1 term distributes. So with these 2 terms, you've got to FOIL here, and you get a squared plus 7a plus 7. If we redefine f to be the square root of x, then plugging in f of 0 is just square root of 0, which is 0. Remember, we can take the square root of 0. What number times itself is 0? 0. F of -1 is square root of -1, which we've learned to be I. But I'm going to say that actually in Chapter 3, we're going to consider this to be no real solutions. We're not. The closer we get to calculus, the less we're going to be concerned with imaginary solutions. It's worth it to ask your teacher, if it's me or not, whether or not in this section we are considering imaginary solutions. And I believe for most of Chapter 3 we're not. We're just going to say no real solutions, although you know that you could be more specific and say that the answer is I. F of a is equal to the square root of a. F of a plus 1 is going to be the square root of a plus 1. You can't simplify these. You don't have to. These are the answers. Hey, any of you ever been to Dover, Delaware? That's the capital of Delaware. It's Dover, and I've never been there. Maybe you have. Tell me about it when you get to class.